Okay, hi, hello. Welcome to section. If you have not already, scan the QR code up here. This is for like attendance things for section. Attendance is not required for section, strongly encouraged, all the things. But for keeping attendance, I do so because in a metaphor, I am like Orgo Mother Goose, and you're all the little gooselings. Goslings. I want to make sure you didn't fall off into a cliff, and so I like to keep track of the little Orgo ducklings. So yes, QR code up here. They will be chemistry themed. There will be a different thing in the center for each section. There's always kind of like a fun question at the end, normally. The first one's kind of like biography information. But hi, yes, welcome. So what we're gonna kind of do today is we'll start off with some like introduction things of like, hi, who are you? Why are you here? Then I will do some like logistics things, which will probably be the least interesting part of the whole course, a very syllabus day kind of activity, talking through all the kind of logistics that Logan didn't have time to cover in lecture yesterday. And then we'll switch over to the iPad and do more kind of like section proper stuff of like normal like content review and some practice. Cool. Well, to start off, hi, welcome. You all are doing a difficult thing, as I'm sure you know. You are both taking organic chemistry and doing it in a condensed 7-week summer. You brave souls, you know? So when I first took like an organic chemistry class at Harvard, I started off with Chem 30, which is like OChem 2. I had done some chemistry in high school, like organic chem, and they put on the door, "Abandon hope, all ye who enter here." And that's very much not the vibe that I want for this class. It has like a very scary reputation, but if you were like here in this room at Harvard to take organic chemistry, you have the ability to succeed in this class. Typically, the only time that I see students run into difficulties in the class are when there are external factors. Sometimes just like life things that happen, but also like organic chemistry is just naturally a hard thing to balance stuff with. So if you are taking another class, if you are working, if you have a lab commitment, like those are all things that are challenging to do at the same time. Not impossible. Everyone, like every year, there are students who are doing these, but just know that organic chemistry is a beast and it's going to want to eat you. So defend yourselves. I'll try to help. Logan, he's great. I'm a big fan of Logan. So I had like done organic chemistry elsewhere and had a few different professors before I started TFing for Logan. And I was like, oh, this is so much better than what everyone else is doing. Like, if I had to forget organic chemistry and learn it from scratch, I would learn it from Logan. I think that he is a more engaging lecturer than most organic chemistry professors who are this monotone, the carbocation. Like, sometimes it's painful. But Logan's a performer at heart, so he makes it fun. Yeah, so to start us off, we're going to do some like introductions. So we'll just go around and answer some questions. Who are you? Preferred name, pronouns if you're comfy. Where are you from? Like, what's your hometown? Where are you at in your education? So one of my favorite things about this class is it brings together learners of various different like ages and like points in their learning career. So we have some high school students with the secondary school program. A bulk of our class is Harvard College undergrads, and then we have students in the extension school, which are either students who are like enrolled at another university and just trying to take a summer class, and Harvard is one that fits the bill, or there are a lot of students who take classes with the extension school doing Harvard's post-baccalaureate pre-med program. So that's kind of the thing of, imagine you went and got like a history degree, and then you said, wait, actually I want to be a doctor, and you like figured that out a little bit later, and you have to take all your prereq requirements. Harvard has like a program where you can just do those requirements for like medical school. So where are you at in your education, and then why are you taking this class? So I bring a lot of energy, but I'm not precious about organic chemistry. I am enthusiastic about teaching. I have the same enthusiasm for calculus as I do for OChem as Gen Chem. So a valid answer is, this is required as a pre-med, or this is required for my major, insert major here. Yes. So the other thing is I'm gonna try to like follow along in like spreadsheet things and maybe take a few notes. So as we are going around, if you see me go like this and then blah, 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 I'm listening. I'm just trying to type. Can we start off? Can we start off in the back with you?
I'm Noreen.
Noreen.
I'm from Florida. I'm a Harvard graduate sophomore,
Work.
and taking this class from Korea.
Very nice. Welcome. Nice.
Hi, I'm Gigi. I use she/her pronouns. Right now I live like here in Massachusetts, but I'm originally from Florida. I'm also a rising sophomore here at the college, and taking this because this is part of the requirements for my concentration.
Which is?
HDRB.
Okay, cool. Welcome.
I'm Matt. I'm from Massachusetts. I'm going to be a Harvard senior, and I'm taking classes as a pre-med,
Work. What concentration?
integrated biology.
Very nice. And also from like Massachusetts, like here-ish or like Western?
Like Central.
Okay, cool. Welcome. Hey.
My name is Ava. I'm a she/her pronouns, and I'm a rising junior in high school. I'm from Boston, and I'm taking this class because I want to take AP Chem next year.
Yeah, this is definitely like a punch above AP Chem, but welcome. You're in good company. I did organic chemistry in high school, and there are many students who like do well as high school students, even though it's a bit scary. So, cool.
Hi, my name is Jack. He, him.
Pause. You are one of 3 Jacks, and all of them are in the same section. So, for the Jacks, can you also say last name?
Edwards.
Edwards. Cool.
I am from Mass. I'm from more mid Mass around Worcester.
Okay, cool.
I am a rising junior up at University of Toronto, so I'm here with the extension school. And I'm taking this course because I want to take the MCAT when I'm a senior, and it said it was good for that, and I need this as a part of my minor.
Cool. Welcome.
I'm Emily. I'm also from Central Mass.
Wow.
And I'm a rising Harvard junior. And I'm taking this class because one, I'm neurobiology concentrator and also pre-med.
Very nice. Cool.
Hi everyone, I'm Jack Wilder.
Okay.
I use he, him pronouns. I'm from Southwest Virginia, and I'm a Harvard College rising junior. I'm taking this class because I'm pre-med. I also enjoy chemistry, so I'm actually thinking about switching my concentration to chemistry. So I'm kind of using this class as like a feeler if I really want to do that.
Did you do PS 11, the Gen Greg Tucci?
Yeah.
Light of my life. He's the reason I got a chemistry degree from Harvard. Gem of a man. So yes.
I
Yeah.
took LPSA too.
Slide.
I lectured a lot more there. It was great.
Yes. Work. Welcome.
My name's Ty. I use he, him pronouns. I'm from Florida. I'm a rising Harvard sophomore, and I'm taking this class for pre-med.
Work. Cool.
Hi, I'm Josie. I'm from Nashville.
There are 2 Josies as well.
Zealand.
Work. Welcome.
I'm from Nashville, Tennessee.
I went to Nashville for the first time this year, and then I went again like 2 months later. I said,
Did you like it?
I did. The Broadway is a lot.
So fun.
It's a lot.
Yeah, it is. I'm a rising junior at Harvard,
Yeah.
and I'm taking this class because I'm pre-med.
Cool. What concentration?
History and science.
Ooh, I love history and science. Wait, history of science or history?
The concentration's called history and science, but like the classes are basically about the history of science.
I guess they changed the name. I think it used to be
Yeah.
history of science.
I-
Okay. Huh. Hi.
guys, I'm Osa. She/her. I'm from South Jersey. I'm a rising Harvard College sophomore, and I'm taking this class because I'm pre-med, and then also integrated biology, history, science concentration.
Ooh, very nice. Cool.
Hi, I'm Adana. I'm from London. I'm a rising sophomore at Harvard, and I'm taking this class also for pre-med, and then I'm studying bioengineering.
Cool. Very nice.
Hi, I'm Skylar. I'm from Connecticut, and I'm also a rising sophomore here at the college. I'm taking
class for pre-med and also just to free up some time to take other classes in the fall. And yeah, that's it.
Cool, welcome.
I'm Christina. I'm from New York, and I'm also rising Harvard College sophomore. And I'm taking this class because of pre-med requirements and HDRB requirements, and I was scared to take Scrub 10 and Chem 17 at the same time.
No, that's very valid.
So I wanted to take those.
Also, what part of New York?
The city.
What borough?
Manhattan, but I
Okay.
don't spend a lot of time in New York anymore. I
Oh.
sorry, I kind of lost my voice.
No, you're so good.
I went to boarding school,
Work.
and since then I haven't spent that much time.
Yeah. I'm going to New York this weekend. My sister lives in Brooklyn, and then I see a lot of theater, and so I like go to New York probably 3 of the 7 weekends for the summer term. So yeah, welcome.
My name's Jaya, she, her pronouns. I'm from Newton, Massachusetts. I'm also a rising sophomore at the college. And I'm taking this because pre-med and HGRB, and I didn't want to take it with Scrub 10.
Very valid. Welcome.
Hi, I'm Sophie, she, her. I'm from Chestnut Hill, Massachusetts. I'm a rising high school junior, and I'm taking this class because I really liked my chem class last year, and I want to see if this is something I want to go further in.
Cool. Welcome. And then for high school, y'all have to take another class, right? What's the second one you're doing?
Epidemiology and
Oh,
biostatistics.
okay. And then you were the other high school student. What's your second one? What was the second class that you're doing?
I'm going to take AP Chem.
Oh, no. I mean the summer school here. Heard. Yeah, like, is that one of the, like, the CS50s? Yeah, CS50 is a little scary, but welcome. Yeah.
Hi everybody, my name is Joseph. I'm from South Texas. I'm a rising sophomore at the college and I'm taking this, I use he, him pronouns. I'm a rising sophomore at the college and I'm taking this class because of pre-med requirement and I'm concentrating in integrated biology.
Cool.
I'm Jack, he's he, him pronouns.
The third Jack.
G, last one.
Work.
I live in Somerville. I have an undergrad degree. I'm in the pre-medical program, and I'm applying to veterinary school this year.
Okay, very nice. Pre-vet. Yeah, I think that there's one other pre-vet student so
I haven't
far.
met them yet.
You know, well, there have to be a lot of coalitions. There needs to be the Central Mass Coalition, the Jacks Coalition, the pre-vet. Yes, it's going to be like a reality show competition. Yes, who will win? Well, welcome to you all. Since I'm the one that's leading up here and I made a PowerPoint, I get to have my own introduction slide. I'm Colton. I'm non-binary. I take any pronouns. I'm a Virgo. I'm from Georgia. I'm a Southern Belle, a Georgia peach. I did my undergrad at Harvard, got a degree in chemistry and music, so a little Hannah Montana, best of both worlds. I was in Elliott, but I transferred to Courier, which have a lot of quad pride. I'm not a quad apologist, I'm a quad supremacist. I like the separation of church and state between the quad and like campus. Courier gets a lot of like grief thrown at it for being like a retirement home. I'm like, yeah, I want to retire. Like I want a calming environment, thank you. I was around like COVID years graduation, and so when I graduated, they emailed me my degree. They later sent like a physical one, but I have a literal file on my computer, my Harvard degree, I guess. So here we are. As an undergrad, my big extracurricular was theater, so I music directed and conducted. I was like teaching the music and like conducting the pit for shows. So this was like a production of Chicago on the main stage, and then this was a musical adaptation of Shakespeare's The Tempest that was kind of more experimental theater. We did it in the Adams House Art Space, which was demolished 2 days after the show. This was a musical Dogfight that I worked on. I live in Georgia, and I'm about 10 minutes away from the University of Georgia. I'm not very sporty, but go Dogs, sure. My main areas are like math, science, and music, and so I'm like close to getting some like additional undergrad degrees in mathematics and biochemistry. I'm also like working towards like a vocal performance thing, but it's also like I'm just messing around taking classes. Like I got tired of like when you're in your undergrad, it's like, oh, I have to do all the requirements, and it's very stressful. And now I'm like, I just like learning, you know? Like, I like taking a class now and then. And then I'll maybe do some PhD programs at some point. But I work primarily as a math and science tutor. So I worked for a company in my hometown, and then I started my own business a few years after that, mostly working with high school and college students of like math and science, test prep stuff. I have photos of my dog Daisy, who I miss dearly, who's back in Georgia with a friend. So if you are a pet person, show me pictures of your pets. I also have a photo of my sweet dad, Stan the man, who I include on here partially because I'm a caretaker for him normally during the year. And so there are some times where I just have to go and take a call, just related to family stuff. So I include that. I also have a little radio tower because I am the CEO of 4 radio stations, which is a crazy thing to say, but it was the family business. And when my dad started having some health issues, I took over the family businesses. So occasionally I'm also making out payroll and dealing with the IRS. It's a time. This is my 8th year TFing S17. It's always a really special experience, and I like being a part of it and helping to kind of set the tone for the class. I started TFing the summer before my senior year of college, and then I've just kept coming back. They haven't kicked me out yet. I also do some TFing with the extension school in the fall and spring from Georgia. But that's me. I'm looking forward to getting to know you all over the course of the summer. Sadly, we have to turn to much less interesting things now, and it's going to be the most boring 25 minutes of the entire term. Are you ready for the energy to just drop? Just let's gird our loins. Let's prepare. Okay, so starting off, what do you have to turn in? So the first thing is due tonight, don't forget, the lecture review quizzes. These are due Wednesdays and Fridays after the lectures that they are over. They are open note. You have 3 attempts to complete them. They are graded based on accuracy. There are no drop quizzes because it's like 3 attempts. These are not meant to be super punitive, like take maybe 10 or 15 minutes max, submit it, see what you did wrong, try to figure out what the issue was, and then try it again. But like all in all, this whole quiz thing should take you less than 30 minutes. Problem sets, 10% of your final grade. They are due Monday nights at midnight. First one's 47 pages. I'm so sorry. Basically, Logan mentioned it, but they are skill builder problems, which is a majority of the problem set, like 37 pages, and then like 8 to 10 challenge problems at the end. And in any other course, skill builders would be optional practice problems. What we have found is in the past, when they were made optional for students, students did worse. And so we are just making the practice problems mandatory. Problem sets are completely graded based on effort. So as long as you've done the old college try and you've like attempted it and seemed like you have put like a legitimate attempt, not just like a scribble, then you get credit for the page. So the whole thing with the problem set is it should be about learning. It shouldn't be a stressful grade thing. You should be getting hundreds on all your problem sets essentially. Challenge problems, the answers are not posted, and before the problem set is due, I mean. And so that's the challenge. You don't have the answers. What this means, also, because problem sets are graded based on effort, you are not really getting feedback until the exams. Like, that's your main source of feedback for the course. So after the answer keys for challenge problems are posted, they'll typically be posted on either Tuesday or Wednesday, depending if there are late PSET submissions. Make sure you set aside time to actually check the accuracy of your challenge problem answers. And for the skill builders, you should be checking the accuracy as you go. Generally speaking, for skill builders, there's a continuum of what you can do, right? So on the lowest end of the continuum, you can copy directly the answers from the sheet and not do any work and just like move your hand across the page. That's not great because you're not learning. Like you're just kind of like checking a box. At the other end of the spectrum, you are a monk. You don't have access to the answer key. You are taking these skill builders super seriously and you're going to do it. That's the hill you're going to die on. And you spend 50 minutes a page. Also not good. Also not good because if you have 37 pages, 50 minutes, that's 37 hours basically. Yeah, who has time for that? You need to do somewhere in the middle. Like do an honest attempt at the question on your own. Like try it out for like 10 minutes and then look at the answer key when you get stuck or when you don't know what to do. Like they are really meant to be like proper practice problems where you are learning as you are going. They are not meant to be a test of your knowledge. It's a tool for you to learn. Kind of makes sense as to like how to approach the skill builders. Okay. Our late book policy is pretty intense. So if it's up to 24 hours late, it's 50% off. And then if it's over 24 hours late, no credit. It's not because we are trying to be mean. It's because as soon as you turn in your problem set, the next one is due in 7 days, like clockwork. And so if you are still trying to finish up the previous week's problem set, you're digging yourself into a hole. And so we want to disincentivize that with a penalty. If you have an issue with submitting your problem set, you should email me as soon as possible with a scan of your problem set. So if you are approaching me like Tuesday at 3 p.m., like, hey, I couldn't get it to submit, you're less likely to get credit. If I get a frantic email from you at 12:30 a.m. being like, I've tried to submit this, blah, 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 I'm like, oh yeah, you were probably trying to, don't send me frantic emails, but like, I can generally tell if you're like, it's a just, you know. Cool. If you're an iPad user, tablets are great for problem sets, and they make it easier to submit to just like export from your tablet. Make sure when you are exporting, you did not add an extra page. So if you add an extra page, or if you have too few pages, it makes it hard to grade in Gradescope, and I'll probably have you like resubmit it, or like it won't be accepted, or a point deduction or something. So make sure number of pages. If you're doing a print copy, so the first one, it's like a free stapled one that we gave out, and the rest of them will be in a spiral bound book that you'll get by the end of the week. Those, you're not going to be able to run it easily through a scanner, so I would just use a phone scanning app. The one that I recommend is Chem Scanner. It's easy and it's free, and it compresses the file so it doesn't become like a 1 gigabyte like PDF for your PSET.
The Gradescope app has a really good scanner. It's a lot better than the other ones. Yeah.
Really? Wait, is it Gradescope iPhone app?
Yeah.
Ah, wow. Okay. Pro tip. Cool. Any questions on things you have to turn in? Yeah.
If everything,
What's your name again?
Joseph,
Joseph.
if everything is answered on a PSET, does that mean like 100% credit?
Pretty much, yeah. Unless it's like we were expecting a big thing and you did one sentence or something, like for a challenge problem, typically. For the skill builders, I'm gonna spend all of 0.25 seconds looking. Is there something there? Great.
Okay.
Yeah, and it will also be a thing of like if it looks like half of the page is complete, you get a half a point for that page. Yeah.
Thank you.
For the PSETs and like challenge problems, are there any short answer questions? And if so, like, do we need like complete sentences?
There are short answer questions sometimes. And I'm the one grading it, so I'm gonna say no. Like as long as it's like really clear what you're trying to say, you can use like bullets. I love a bullet. In fact, I hate 20 sentences. So yeah, be short and to the point. Yeah.
Sorry, I haven't done it.
And also your name.
Osa?
Osa.
My second question is, for like rounding decimals, like how many like decimal places would you like, or do you want
It's just not really it's not relevant here.
Yeah.
Like the only math that you were going to do is adding up eclipsed and gauche confirmations, like energy cost. There is no more math for the rest of the course.
Great.
Yeah, Gen Chem is very math. It's basically like glorified math word problems. OChem is like, how do things react? How do molecules exist? It gets a little bit more like, whoo. Also, I am horrible with names. By the end of week 3, I will have everyone's name because pure shame will drive me. But while I'm learning people's names, when you have a question, can you be like, hi, my name is blank, my question's this, or something, just to help remind me, and then you can stop doing that when I prompt you for your name. So if I'm like, oh, so what's your question? Then I assume I know your name by then, and then you don't have to do that anymore. Cool? Cool. Moving on, exams. The exams are 65% of your grade. I'm so sorry. Part of it is the way that we approach organic chemistry is we think of organic chemistry mostly as a skill rather than a set of knowledge for you to know. And so the main way that we can assess a skill is with an exam. So the midterms are each 15%, the finals 25%. Organic chemistry is inherently cumulative. So specifically like in lecture 3 is when you're gonna learn your first reactions. You will need to know those for the rest of the course. They will be actively used in exam 2. However, the first exam has some topics that are just kind of like intro stuff that's not really gonna come back in exam 2. So for example, do you remember the Newman productions that y'all were doing of like the rotation of bonds? That's something where you're 100% going to have an exam 1 question on it, and you're 100% not going to have an exam 2 question on it. So that's kind of the scope of why we say like exam 2 covers lectures 1 through 9. It's going to be on the reaction side, the things that are all integrated together, rather than those one-off skills from the intro lectures. The exams are graded on accuracy, correctness, not effort. So just clarification. Group exams. So we've done group exams every year, but this is the first year that we are doing the group exam as a take-home group exam. So normally what we would do is we would have you come and take an individual exam, and then afterwards we would put you in a group and have you do it in a group in the lecture hall. What we're going to do this time is on exam days, you're going to come around 9:45, and then you're going to take a 90-minute individual closed note exam from 10 to 11:30. At 11:30, when you hand in your individual exams, on Canvas you'll be assigned to exam groups. And these are going to be groups of 3 to 5 people assigned randomly. And then we're going to ask you to meet up with your group and make a plan for when y'all are going to meet and do this exam, group exam. The group exam is the exact same as the individual exam. You're just going to be working with others, and it's going to be open note. But you should do it together. It should not be like, let's rip up the pages. You do these 3, you do these 3. That defeats the point of it. The whole purpose of the group exam is to get you to re-engage with the exam, to like learn from what you missed. Because when you're with 3 other people, pretty quickly, you realize what you did correctly and incorrectly on that exam that you just turned in. We'll typically have the exams graded by the Monday night after the exam, and so you'll know your scores going into Tuesday's lecture. The grades. So the individual score that you get on your individual exam is 80%. And then the group exam score is 20%. And so the composite of those, of the 80 and 20 split, that will be what affects your actual course grade. The group exam can only be used to help your score. It will never lower your score. There have only been like 3 instances ever in the past 8 years where someone's individual score was higher than their group exam score. Typically, the group exam scores are like 95 and above. They're really fun to grade because they're super quick. Yeah, so that's group exams. Now, the other thing is like sometimes it just takes another minute for information to click. And so like if your exam 1 score is not the greatest, you are not doomed for this whole class. Like I've seen a lot of students struggle in exam 1 and then exam 2 come back and strong and do well in the course. And to kind of reward that, your best exam score is weighted an additional 10%. So, and sometimes that's even your final exam scores. And in fact, I would say for most students, their highest score is either exam 1 or it's the final. The other kind of thing I'll say about that for your first exam performance of, I don't know exactly how to talk about it because y'all don't know stuff yet about what you're going to be doing, and it's hard to describe until you're in it. But the game that you play for exam 1 and exam 2 are very different. Like they are different struggles. Exam 1's all this like intro stuff, what are molecules, naming, MO stuff, and then baby reactions. Exam 2 is reactions all the way, and it's just like a different skill set. So just because you like perform poorly on exam 1 does not mean you will perform it poorly in exam 2. Flip side, if you did well in exam 1, that does not guarantee you will do well in exam 2. They're different games, so just heads up. 2 practice exams will be posted on Canvas about 5 days before, and we'll also give printed copies in lecture. I will send a long, kind of scary announcement on how to approach those and like when you should do it, because you also have like a problem set looming, and like we are on a very condensed schedule. So we have strong recommendations for those. Participation's 10% of your grade. That's split between 5% those quizzes, lecture quizzes, and the other 5% are the Poll EV participation stuff, which Logan has already sent stuff out about. 100%, woo, yay for the first lecture. Yes, 2 lectures, whichever 2 lectures have your lowest Poll EV score will be dropped. There will be no like excused absences because you have those drops. So if you have like a doctor's appointment or whatever, that will just be one of your drops. Cool. Questions on exams and participation? Yeah.
Is there a group exam in the final?
No, there is not. That's a good question. In name? Josie. Yeah.
Skylar. The best exam score, will that include the individual and group exam score?
Yeah, it will be the composite. Yeah.
Thank you.
Yeah. Yeah.
I know there's a course schedule, but I can't pull it up right now. Are the exams on Thursday?
Yes. Not every week. So the first exam is 2 weeks from tomorrow. So.
Are there lab meetings though?
Yeah. Not for the final exam week, and I forgot about exam 2. If that might be the week of the last. No, actually.
I don't think we have labs.
Yeah. So there will just be a lab the week of exam 1. Yeah.
Christina.
Christina.
The exam reviews, I saw that in the schedule, but I didn't see a time. Those are
They're in the updated one. So I'll be offering them the week of the exam. There are going to be 2 offerings of them. They're going to be exactly the same. One will be on Monday evening, and those are for students who are already done with their PSET and have already started studying a little bit. And the other offering will be on Wednesday morning. So there are going to be kind of 2 opportunities to see it. It will also be recorded. So, yes.
there's
Good.
never going to be anything for this course on a Monday morning.
Correct. Other than, I think Logan has like mid-morning office hours. But yeah. Cool. Section, my favorite part of the class. Ugh. So those of you who are Harvard College students, you kind of know the drill with what is section, but for those who are not undergrads here, section is meant to reinforce lecture. No new materials introduced. Really, the way I kind of think about it is y'all had a 3-hour, 8:30 a.m. organic chemistry lecture in the summer. So I assume that y'all were run over. Y'all were traumatized. No information stuck, and you maybe got some vibes of things. And I am coming in like your kind of peppy cruise director of like, okay, what happened? How do we use this to do the problem set? What are the like 4 big things? Like, I'm trying to kind of do a focused recap of it, and then also to work some problems with you. The overview of section structure is I'll do a brief like outline of what was the lecture, what were the big topics, and then we will kind of go in more depth about on like 3 to 6 topics, I guess, depending on the lecture. On Fridays, sometimes as a part of section, I'll incorporate these extra challenge problems. They're extra challenge. They are not extra challenging, they're just additional challenge problems, and they are ones that are not part of the problem set. These are like truly optional practice. If you request print materials, they will be in the spiral bound, and then if you are using digital materials, the PDF will be posted on Canvas. But the only thing I ask is that you don't look at it before coming to section if we're going to work on it. This is just for us to practice how do we approach these exam level questions, seeing it for the first time. Like what do we notice? How are we kind of like picking up context clues here? And I think I forgot to say it earlier, but challenge problems are exam level problems. They feel a little bit harder on the problem set because it's the first time you're seeing it. But on the exam, it will be the same difficulty, but it won't be as foreign to you. I already said not mandatory, but taking attendance. My pitch for coming to section is my only job is to help you learn and to grade your exams. So like I've spent a lot of time thinking about where students struggle in this class, and a lot of that effort and energy on my part is put into section in terms of like what we cover and how it's covered. My communication preference, primarily via email. I don't like the Canvas like user interface as much. Yeah, I have the type of preferred email on the paper going around that was like before all the QR codes. Now we're high tech. I try to respond pretty quickly. Like sometimes I'll be like walking down the street, get an email, respond within 2 minutes, and I feel real fierce when that happens. Generally, I try to do it within 24 hours, and if not, I know how Harvard works. Send me a bump email, annoy me until I answer you. Like, let's do it. We'll get it done. I don't want me to be the limiting factor to you getting an answer. Sometimes if you like ask a content question via email, I might be like, hey, this would be easier to talk about in person, just to like verbally explain things, but generally I'm available via email. Also, these slides, by the way, are posted on Canvas. They are under the General tab under Detailed Course Logistics. So I just saw people taking photos, and I'm like, it's already posted. Section notes. So the blank section notes will be posted before class as a PDF. And then I'll also try to post annotated ones after class. We can't provide printed copies because I use so much color on them that this one book costs like $40 to print, which is crazy. So if you are a non-tablet user, what I would honestly suggest is just take notes on paper and think about like what you don't need to write. I try to treat these almost like a condensed review sheet for each lecture. So lectures sometimes have 20 plus pages. This is going to be like a 4 to 6 pages targeted condensed version of like the main material you need to know. But if you are an iPad user, sometimes it's just helpful to put on your iPad and have it for a section. The problems that we are doing primarily in section come from the problem set, either skill builders or challenge problems sometimes. So you can also just flip to your problem set and like work them on the problem set. Yes, I also format the section notes as 2 columns just because I'm primarily using a tablet and I like to zoom in. And so it's kind of a teaching aid and compressed review document, but that's kind of the philosophy on section notes. Lastly is videos. So I record all of my section videos and post them on YouTube/Canvas. And all the section videos from last summer are also posted and they're on Canvas in a playlist. So they're all recorded. Why should you come to section? So I really think that like this is not a spectator sport for organic chemistry. You have to like do problems, get your hands dirty, and like part of it's just like the accountability of showing up. So the other thing I've seen is students who start off not coming to section, who then struggle, have a hard time starting to go to section. Like it's just like a feedback loop where like it never quite catches up. And so I would say start going to section, and if after the first exam you're like, I don't need this, totally fine. But like I would rather set you up for success from the beginning to go onward. It's also like because this is like Orgo boot camp, whether you like it or not, you're gonna be spending a lot of time with these people and y'all are kind of going through hell together. And so like, why not like camaraderie, like support, like make friends, like, I don't know. This doesn't have to be miserable. Any questions on section? Yeah.
Will the sections always be in the store?
Yes.
So like we like signed up for the 11 a.m. section, but like if one day you can't go to 11, can you go to other time?
So yes, however, 9 a.m. you'd be fighting for a seat. The 1 p.m. is pretty open and we have some more availability in here. But like 2/3 of the class did 9 a.m. and then after section I got like 10 emails of like, actually I have to go to 9 a.m. because of lab or blah, blah, blah. So it's harder to go to it, but you can always try. I just can't guarantee that there will be.
So like if you wanted to go to like say 1 p.m., would we have to like email you or should we show up?
Honestly, it's the same to me. You like you do whatever feels right.
Okay.
Yeah. I don't care that much, but sure. Also name. Emily. No, good. Cool. Some resources. So TFs, I guess TF singular. Again, feel free to contact me. Sometimes easier to explain things verbally. Also, I call them the like interstitials. So I like made a break of 30 minutes between my sections intentionally to answer student questions. I also am typically around before and after like lecture and section, so you can always like hang around and ask me questions. Help room, which I'm going to talk more about. That's our course's version of office hours. It's on Monday. Logan does sometimes mid-morning, early afternoon, and then I do sometimes in the late afternoon. And it's primarily to like work on the problem set, but also we can go over conceptual questions and things like that. Things to get, I know you've seen this several times now. Model kit, don't buy the $200 one and the coup, just like get whatever's cheap. You just need something to visualize atoms with. There also are model kits that you can check out from Cabot Library over here in the basement. You can check them out for like a few hours. I think there are some that you can check out for the whole summer, so that's there. There's not really a textbook. Logan and I both talked about OChem as a second language book. It taught me OChem too because I had a horrible professor. But this is kind of important context for this class. For those of you, like, because you're taking it, you should know what you're taking. Harvard teaches organic chemistry differently than almost every university in the United States. So in most like state schools, there's a 2-semester treatment of organic chemistry. And what we do here is S17, or 17 in the fall, takes the most important topics from OChem 1 and 2 that are relevant for biology and biochemistry. So we cover a lot of things from OChem 1 and OChem 2, but we don't cover as much as in a normal 2-semester state school orgo sequence. Then our OChem 2 at Harvard, Chem 27, is essentially biochemistry. You are learning the mechanisms of metabolism. It is not organic chemistry content that is covered in any other OChem class in the country. So it's a really weird kind of system. But the reason why I bring this up is, one, to point out the fact that we are taking actually a year's worth of organic chemistry content, squeezing it into a semester, and squeezing that semester into 7 weeks for the summer. So, and then the second thing is because the OChem as a second language is written for all the students who are normally doing a 2-semester sequence of organic chemistry. So we are going to cover topics that are in both the first semester topics book and the second semester topics book. And so I have a table here, a concordance table of like which lectures correspond to which sections in which book. So like lecture 3 is content that's typically covered in OChem 2. So it's in the semester 2 OChem the second language books, and it's these chapters. Then lecture 4 is typically semester 1 content, and it's these chapters. So I've tried to help you out if you do want to use those. I love them. They are super, super like direct language. It doesn't feel like a textbook. It's lots of like quick practice to build skills. It's like high quality. Last thing here is academic tutoring services. So this is like a DCE thing where you can get like free tutoring for up to 2 hours a week for this class. So if you are interested in that, take advantage of it. I think that it starts next week, but you can like fill out the form and get on the list for it. Let's talk a little bit about Help Room. So this is more of a like rude awakening for the students who are used to Harvard College undergrad pre-med classes. For those classes, you have a core staff of like 15, and we have office hours every day of the week, and there are Zoom ones and all this. Y'all outnumber us. It is just me and Logan. And so what that means is, especially because it is so condensed, there's only one day of Help Room things, there will often be like 25 students and then one core staff member. So because of that, we can't do traditional office hours of just like one by one going around answering questions and then have people just wasting their time like queuing for most of that time. Like that doesn't make sense. And so we are really like leading into this is a collaborative. Like specifically, we want when you come to Help Room, you to be working with other people. If you are alone in Help Room, I'm going to be like, hi there, can I introduce you to blah, blah, blah. When you have a question also, we are going to be prioritizing answering questions that a group has. So if you are going there to ask individual questions, if there is any group that has a question, they will be answered before your individual question. And part of it is, again, outnumbered, but part of it's like we want you to work together and figure it out. It can also be a thing of like, if I work with a group on challenge problem 3 and then I'm doing other stuff and then another group says, challenge problem 3, I'm really stuck. I might be like, have you met these beautiful people over here? They have a really great explanation. And you practicing teaching your peers and working through that is going to make you know the material better for like exams and everything going forward. So if you have individual questions, totally fine. You can email your questions. You can do the interstitials before and after class section. Or like if Help Room's kind of dead, you can ask individual questions, but that's kind of the venue for those kind of individual things. We really do want you all to be working together. So can I get like a thumb meter? Do you understand expectations for Help Room? Cool. Separate question, reset. How do you feel about the expectations for Help Room? Feel free to be honest. Okay. No, if I was in your seat, I probably would have done one of these where I'm like, I'll try it, but like, I'm not looking forward to it. Again, it's boot camp, so like you're in the trenches together. But we'll try to make it work. Let's talk about grades real quick. So the final grade cutoffs on the syllabus listed are the cutoffs for like A minus is 85, B minus, or like B minus to C plus is 70 or something like that. But we just don't have the plus minuses posted, and it's because it's different every year. So the way that we do it is a binning approach. So what we do is at the very end of the class, when we have everyone's final raw like calculated grades, we look at all of the data, and like this is from like a real year a few years ago. And we essentially look for a gap in the data. and a gap that would separate kind of one group's understanding from another. So let's look here. If we go down trying to figure out the AA minus cutoff, we have some super high ones, lots of 94s, lots of 93s, lots of 92s, and then we jump to 90.6. Do you see how there's like a pretty big gap here that does not exist really anywhere else? So that is where we did our AA minus cutoff. So everything above the 92.21 that year was A, and then below was A minus. And again, like it's based on the data at the end of the term. So like if you ask us, what's the cutoff for A minus? I'm like, I won't know until you get your grade back, basically. Then for the hard ones that are listed in the syllabus is like 85. We're never going to raise the cutoff above 85. We might actually lower it. So if we look here, where do you think that we should do the cutoff for A minus to B plus? Any suggestions?
After 83.3.
Well, how about the next one's 83.31?
84.87 to 83.9.
I like it. So here there was a 0.92% gap, which is kind of larger. So we did make it a little bit more generous, but only by like 0.2. But then there have been some times where the cutoff for A minus was like 81. Like it totally depends each year on the data. And typically when we see a gap in the scores, that means that there's a difference in understanding between the students who scored higher and lower. And so that's kind of our philosophy. We want to be transparent about how we do it. But yeah, questions about the grade binning? Okay, I'm almost done. Advice. My teaching philosophy is I'm here to help you. I want to advocate that you get points whenever possible. I'm not trying to like demerit you to death. But yeah, this class kind of takes over my life in the summer. And so I'm excited for it. Yeah, I've been looking forward to this for months. Now, other advice. 35% of the class between homework, lab, participation are points that are totally within your locus of control. So try to maximize those points and get near 100% on that so you have more buffer for your exam scores. Take the skill builders seriously. And I wish I had a little transition, but not too seriously. Because again, there have been students who have like killed themselves over the skill builder. Not actually, like students who've done too much on the skill builders, I would say. So we've already talked about how to approach them. If you don't attend any other section this summer, I'll be sad. But the most important one of the entire summer will be next Wednesday, section 3. Section 3, I'm going to do my first kind of session of how to study organic chemistry reactions because it's just new information. And most of you will never have had to learn information like this before. A bio class, you can just memorize things. You can make flashcards. For a math class, you learn an algorithm for how to approach a type of problem. What do you do when we present you with a bunch of visual information that's about how molecules like to react or are stable? It's just a new skill. So I want to like go over some of those skills of how to study it with you. I also recommend that you make a schedule for this class for your even study time and like working on the homework and kind of stick to it. Just treating it kind of like a job, clocking in and clocking out. And so a typical week in this class might look something like this. If you have your lecture, lab sections, and then literally just make blocks of time for the other things you have to do. The thing that I think would be keep you best on pace for this course is when you have a Tuesday lecture, try by Wednesday night when you're completing the quiz and everything, try to have the skill builders for that lecture done. You'll see in the problem set it's split up between the Tuesday lecture and the Thursday lecture skill builders. So it would be Tuesday, Wednesday doing the Tuesday lecture skill builders, Thursday, Friday doing the Thursday lecture skill builders, and then that frees you up over the weekend to do your actual like studying and to do the challenge problems and attempt that before coming on Monday to help room, and then like submitting that. Yeah, so that's kind of what I would recommend. I also put sleep on the calendar because if I don't put it on the calendar, I sometimes forget, you know. But yes, in total, I think that the workload for the class is like 22 to 28 hours. It just kind of is what it is. We're not trying to like be like, it takes a lot of work. Last thing I'll say, oh, go ahead.
So I have a question.
So.
With the organic chemistry as a second language book, how would you like integrate it into like your main study schedule?
Work. I would either try to do it with the lecture topics. Like it might be a good like regroup after lecture to like read through the chapter and like work some problems and then go into skill builders. Or alternatively, you do the skill builders, see what you do and don't understand, and then go to that targeted section in the open the second language. But it's kind of a preference thing. Yeah. Any other questions on like the logistics and everything? Last thing I will say is just reach out for help when you need it. We're here for you. So let's take like a 2-minute break. Stretch your legs, check your phone, do whatever you need to, and then I'll switch over to the iPad. We'll get into like section proper.
Oh, okay. So yeah, you're literally right there. Yeah.
Wait, where in section S are you?
Oh, okay.
That's funny that I never meet people from San Francisco or from Boston.
That's why.
I do with the extension school because they have like a Zoom section, so I lead the Zoom section from Georgia. Yeah. And I think if I was in Boston, I would be doing the college version too. Yeah.
That's one of my first semester in the extension school, like remote from the kids.
Yeah. Yeah, I mean they have it as a pretty like well-oiled machine by now. I've also heard not great things about some of the post-bac classes, so.
I'm just talking about chemistry. Greg teaches chemistry.
Immaculate. I'm so sad I never took his class because I came in having already done Gen Chem, and so I kick myself every day that I didn't take Greg Tucci's Gen Chem. But I like the Chem department. I think that they're pretty solid. He was my advisor. He's the advisor for chem majors. And that's why I became a chem major, actually. Yeah. No, this is actually. No, Apple just does this. If you display a device, it does 9:41 a.m. because that's when the like original, like, here is the iPad like thing. I know it's goofy. Okay. So let's circle back up and get into section proper. So I'm going to spend a little bit of time talking about like the structure of these section notes, specifically talking about this first page. And then going forward, I will not spend any time in any other sections really talking about the first page. So I'm just kind of giving you a layout of it. Firstly, if you came a little bit later, didn't scan it earlier, if you could scan and fill out the attendance QR code, that will always be up here. Then I will always have an overview of what we're doing in section. So we've done the outline, we've done the introduction section, and then these are kind of the topics that a section would cover. Now, because we had to spend like 40 minutes on the boring logistics stuff, I can't get through all the topics that I would want to cover in this section. So the 4 things I would want to talk about for the first lecture are some basic skills in organic chemistry, resonance and arrow pushing, nomenclature, and conformational analysis. And so I have made an executive decision, which is I decided that we are going to be covering the basic skills in resonance together, and I've made videos for these 2 other topics, the nomenclature and conformational analysis. So you can see them. There's just a QR code. It takes you to a little YouTube video. It's like a roughly 15-minute video for each nomenclature and confirmation analysis. Now you might be like, Colton, but those are the new ones and the ones I'm not very good at. And I'd be like, that is true. But they are also isolated skills. So like they are a one-off thing, whereas the basic skills and the resonance are foundational to everything going forward, especially tomorrow's lecture. And so there are some specific things that I want to talk about with how resonance works and also with like drawing orbitals that is going to help you for Thursday and kind of reinforce some things in lecture. So that's kind of why I've chosen to kind of prioritize those. It's also like, especially for confirmational analysis, it's a very visual skill, and so it's hard to kind of teach that as a group. I highly recommend the OCHM as a second language confirmational analysis. Like it goes through step by step, but also my section video, I've tried to take a stab at it. Then I will always have an outline of the lecture content because again, it's like 20 plus pages, and so it's just kind of like, what happened? So I group them together. I also try to like highlight things that are more important or less important. So like two foundational heavy tested things are functional groups and resonance. Functional groups we're going to talk about at the beginning of section 2 on Friday, so that's coming. And then resonance we'll talk about today. And then the kind of more important concepts that come and make these larger sections are typically these yellow things here. Gray means that we're not explicitly testing it. So like we're not going to be like, oh, okay, what's the molecular and electron geometry of that? I know that's Gen Chem. Anyone who says that organic chemistry is only memorization is lying to you. Anyone who says that there's no memorization is lying to you. It's somewhere in the middle. So I try to explicitly list things that you need to memorize. And Logan, I think, also kind of did some of that. And then also I just list out like a few kind of skills to develop. Then at the bottom, there's like a memes section. Most of the ones today are pretty generic because y'all haven't really learned much yet. But they will get more specific as we go. Last thing down here is general feedback for section. So I love feedback. I do a lot of like fiddling with notes every year. These notes have taken on a life of their own over the past 8 years. They used to be handwritten. They used to not be planned. They used to be right on the chalkboard. And now it's like this like yassified little thing. So if there are things that you like or don't like about section, let me know. I will genuinely like incorporate feedback year to year. I make changes every year. Yes. And it can be anonymous or not. Any questions about front page overview section things before we jump into real stuff? Cool. Okay, we are going to start off with basic skills for organic chemistry, and I'm going to go pretty quickly with these. First off, formal charge. So when you were in Gen Chem, formal charge was math. It was a formula. And the plug that I'm going to make is for organic chemistry, this needs to become a passive visual skill, where you are not calculating each time you see any of these atoms. You are just knowing, oh, a carbon with 4 bonds is neutral. Oxygen with 3 bonds, positive charge. Nitrogen with 1 bond, I don't know, or nitrogen with 2 bonds, negative. But you want it to be like you see the atom and you know what charge it should be. So let's try just using these as a visual guide, not doing any math. What should the charge be on this carbon? Neutral, 4 bonds. What about this one? Neutral, good. What about this one? Negative. So 3 bonds in a lone pair is negative, 3 bonds no lone pair, positive for carbon. Then what about this oxygen? Negative. So oxygen with 1 bond, I think about it like OH minus. So 1 bond, negative charge. Then what about the one in the middle with 3 bonds? Positive, like H3O plus. And then one at the end with 2 bonds is neutral. Quick. Then skeletal structures, please use them. My intro organic chemistry class for a year, we only did the condensed structures where we were drawing all the hydrogens, and it made me not happy. So every unlabeled and or bend is a carbon, and all CHs are implied. One thing that is not implied is formal charge. So formal charges have to be explicitly listed, but you can imply lone pairs. So let's try some of this. So here, we know explicitly that this oxygen is neutral, so how many lone pairs does it have? 2, because oxygen neutral is 2 bonds, 2 lone pairs. What about this oxygen, how many lone pairs? 1, 3 bonds, 1 lone pair. So it's kind of like we took one of the lone pairs in the original 2 bonds, 2 lone pairs, and we turned that into electrons in a bond. Now, we can imply hydrogens on carbons, but not on non-carbon atoms. So any other atoms we call heteroatoms. And so like this oxygen, if we just had oxygen here with a plus, that doesn't make sense. You have to list if there's a hydrogen on a non-carbon thing, you have to write it out. Let's do practice. So this carbon up top, it's neutral, so how many hydrogens are on it? 3, great, because we need 4 bonds. What about this carbon? 2, great. What about this carbon? 0. That carbon already has 4 bonds, so there are no hydrogens. What about this one? 0, because remember, if we have 3 bonds and a positive charge, that means that we have an empty or vacant p orbital on there, so no hydrogen. Cool. Now, if we are going from a name to a structure, heptane, we look for the prefix here saying that we have 7 for hept, and we literally just 1, 2, 3, 4, 5, 6, 7. Easy. Then, if we have a longer name, we always start at the end. The end gives us our kind of parent, so pentane, 1, 2, 3, 4, 5. And then what is a hydroxy? What elements? OH, hydrogen, oxygen. And we need to put it on position 2. Does it matter whether we count from the left or the right? No, we are God in this moment. So whichever way that we choose is the way, the truth, and the light. Moving on to hybridization. So this might be a dated reference. Does anyone here recognize the game Cooking Mama? Some Cooking Mama fans out here. So I think about hybridization as Cooking Mama. You have your atomic orbitals, the s and 3p orbitals, out on the side counter. You have your Cooking Mama pot. And if you want to hybridize all of them, you put all of the orbitals in, stir, 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 and they pop out as hybridized orbitals. And the important thing here is however many orbitals go into hybridization, that's how many orbitals you have coming out. So if we hybridize 4 orbitals in s and 3p's, we get out 4 sp3 orbitals. If we only hybridize in s and 2p orbitals, we're putting 3 orbitals in, we get 3 hybrid orbitals out. And then that p orbital that was left on the counter is still there and is still a pure p orbital. sp2 is the same kind of thing. So why do we do this? Generally speaking, it's to spread out electrons maximally as much as possible to limit repulsion of electrons. So when you have 4 electron domains in your sp3 hybridized like this, that winds up being this tetrahedral shape, kind of spreading everything out, 109.5 bond angle, all that. sp2, spreading out 3 electron domains, that's going to be trigonal planar, 120 degrees. And then sp, that's linear. And you can see that for these sp2 and sp, we still have our pure p orbitals, and these are always going to be perpendicular to the axis of everything else that we're doing. So yeah, these orbitals, hybrid or atomic orbitals, go in and make bonds. Sigma bonds are head-to-head overlap between the nuclei of 2 atoms, whereas pi bonds are lateral overlap, like above and below the nuclei. And because of this, pi bonds are only between p orbitals. So that's kind of the important fact from this. Then if you have a multiple bond, you always are going to have a sigma bond, and then any additional bond is a pi bond. So a triple bond is sigma and 2 pi's. So looking at this, let's go to this skill builder here, where we have HCN. I want to call her hydrogen cyanide, but that's not her name. I'm forgetting her name. I'm a bad chemist. But we have her. What we need to do is we need to assign hybridizations on each atom. Then we need to list out all the bonds, like sigmas and pi's. And then we need to say which orbitals are going into which bonds, and we're going to draw it. So we're going to do this mostly together. So starting off for this carbon, what's its hybridization? sp. So it has 2 electron domains. Remember, a multiple bond is just considered 1 electron domain. And 2 electron domains from our little table is sp. Cool. What about this nitrogen on the end? sp. What's the second electron domain? Because I only see 1. Lone pair, because we can imply lone pairs, especially when it's neutral. So this is also sp hybridized. What's the hybridization of this hydrogen? It's unhybridized. It's just S. Remember, it's on the first row of the periodic table. There are no p orbitals, so it can't combine with anything else. So, okay, that's like our breakdown. Now, we have this single bond between C and H, so this is going to be a sigma CH. And then this multiple bond here, we can do as a sigma and 2 pi's. And I'm going to do some color coding. So let's do a sigma Cn. Then we have a pi Cn. And we have another pi Cn. So now, when we are trying to draw like an orbital sketch of this, we need to think about, for each of these bonds, what are the 2 atomic orbitals coming together to make that bond? So between C and H, well, H only has one thing that it can contribute to the bond, right? So we know it's the s orbital and the H. But then carbon, hypothetically, it could be the sp orbital or it could be the p orbital. Which is the actual one in the sigma CH bond over here? The sp, why?
Because P is only B for the pi.
So close. So like they can be in sigma bonds. However, we have 2 pi bonds, so we need those 2 p orbitals for those pi bonds. So right idea, yes. Go ahead.
Oh no, I said close enough.
Yeah.
Almost.
I'm being pedantic.
Not quite.
So our s orbital we draw just as a sphere. And then for an sp orbital, sp, sp2, sp3, we draw them basically the same. We do one big lobe and then a little nub. And then I might draw and drag this so they overlap a little bit more. So this is a way that we would show the 2 atomic orbitals going into that bond here. And so I will also go through and just kind of group these together. So these 2 orbitals need our sigma CH. So now let's do the sigma Cn. Because of the same reason that we talked about where we have to reserve those p orbitals for the pi bonds, we know our sigma Cn is going to be between sp orbitals on both carbon and nitrogen. So big lobe, little nub, big lobe, little nub. And then we do our shading. So if you have 2 orbitals overlapping, they should be shaded the same way. When you have like a p orbital or when you have like an sp3, sp2, sp orbital, you have 2 lobes and they need to have opposite shading within that orbital. So you just arbitrarily pick one. Logan's going to talk a little bit more about the shading tomorrow when we do MO theory. It's related to like the wave function, like the mathy side of where these orbitals come from. But don't worry about it too much for now. Okay, then we need to do our pi bonds. So let's do the pi Cn. We know our p orbitals need to be perpendicular. So I'm going to draw them up and down. And sometimes we can also just draw like a little arch between them to say, hey, these are connected because they look far away. So that's going to be one of our pi bonds. And then for our other pi bond, it needs to be perpendicular to the other 2 axes that we have here. So if we think about kind of a vertical axis and a horizontal axis that already exists there, we need the next one to come kind of in and out of the page. So we're going to do it like this. Boop. Okay, well there's one orbital that I didn't put on here. What's going on in this orbital? That's where the lone pair is. So we are just going to have like an sp orbital here on the end, and we have a little lone pair in it. So this is kind of the level of understanding that we want you to have between the orbitals and the actual structure of the molecules. And this dictates the geometry for molecules. It's also going to dictate how molecules react. And you're going to get a lot more of this in lecture tomorrow, and you're going to talk about how eventually we're going to stop seeing these as different atomic interactions, and we're going to be thinking about them as molecular orbitals. But I just wanted to kind of do a little like punching up of this. I think one of the challenge problems has you drawing these cartoon orbital representations. So I want you to have seen all of it. Any questions on this before we go on to resonance? Yeah.
When it comes to
Skylar?
Yeah,
Work.
Skylar, sorry. When it comes to like the shading and the like the density, for the 2 p orbitals, will they always will the shading always be like both on the top of both of them? Because I
If it's a
I know for
bonding.
the red, like obviously the red, the density side, like positive's gonna be on top and negative on the bottom, but like for the blue one, does it matter where it is or just
They so Logan will do more of it tomorrow, but if it's a bonding interaction, then both the same either top or bottom need to be shaded. So they have to like match.
More so the like red versus blue. Like I know there are.
Oh no, that doesn't matter. Yeah. Yeah. Christina.
On the P set, there was a question sort of like that where it's like describe how each of the orbitals is used for
Mhm.
sigma bonding, pi bonding, lone pairs, etc., and how these orbitals form the carbon-nitrogen bond. And I was kind of like I understood like the information, but
Yeah.
didn't get how you would most want to see it like answered. So
This.
exactly
Yeah, I
like
think this is literally the question. Slave.
So yeah, that's what. So we should like do the thing that you did over on the right.
Yeah.
But should we? It doesn't ask to sketch, so we don't
Cor-
have to do that.
correct. For
So
that
just-
skill builder, you don't. This is more to set you up for lecture 2 and a challenge problem.
Okay, so going like that and then like saying where the bonds are.
Yes, this would be a complete answer.
Perfect. Thank you.
Work. Okay, let's talk a little bit about resonance. So I'll start off with benzene, classic example, C6H6. So it looks like on the Lewis structure it alternates single and double bond. And we know from Gen Chem times that double bonds are shorter than single bonds. So we would expect it to go short, long, short, long, short, long all the way around. But when we actually measure it, all the bonds are the same length, and it's kind of between a single bond, double bond length. What's going on? So I like to think about resonance as a failure of our notation system. Lewis structures are great. They can tell us a lot of information, but there are certain instances where Lewis structures cannot accurately describe what the real bonding is of a molecule. That is what happens in resonance. In resonance, we say that we need multiple structures to communicate what the real bonding is of the molecule. So we can imagine these two Lewis structures are not exactly what actually exists, but if you kind of blur your eyes of these two, the real thing is somewhere in between. We have kind of 1.5 bond lengths. So it's between a single bond and a double bond for each one of these. And so I really like this metaphor of like unicorn and dragon don't exist, but rhino does. And it's kind of, we're taking glimpses of it from different angles. These do not interconvert. Again, this is just a failure of our notation, so we need multiple structures to describe what's really going on. Key ideas. First one, why does resonance happen? Well, resonance happens, this notation thing breaks down when electrons delocalize. And by delocalize, we mean spread out, like go out from your local area. So instead of just having like a double bond here, a double bond here, double bond here, all the p orbitals are right next door to each other, and the electrons can just spread out, and especially here, they form a little happy hamster wheel where they just kind of run and run and run and run and run. Now, why do they do this? Well, it's very stabilizing to spread out electrons. Remember, electrons have a negative charge, and things of like charge repel each other. So when you're able to spread out your negative charges over more physical space, it's more stable. And there's a catch with this. Why doesn't everything delocalize? Well, if I had the option, I would delocalize. It's because you have to be in a p orbital in order to delocalize. When you are in like a sigma bond, your electron density is physically between two nuclei. So if you were trying to spread out, you would run into a nucleus. Like there's a barrier in the way. Whereas if you're in p orbitals, your electron density is above and below the nucleus. And so if you have a parallel p orbital next door, you can just spread out. So electrons have to be in p orbitals to delocalize, and that's why we have all this resonance nonsense. Cool? Ish. I know I'm going quick. I'm sorry. Second key idea. The more stable a resonance structure is, the more it gives us an actual idea of the real bonding in the molecule. So, for example, I'll start off with like, imagine we have this carbonyl, and I'm going to draw a resonance structure where we have this. This one is neutral. This one is charged. So which do you think is going to contribute more heavily to the actual bonding of the molecule? The neutral. It's more stable. Moreover, like this has fewer charges, but also this one on the right has an incomplete octet with that carbocation in there. So Yes, it gives us, the more stable something is, the better it tells us about the actual bonding. The other thing to think about is charges. So let's say you had a negative charge and you had the choice to put that negative charge on an O or a negative charge on a nitrogen. Which is going to be happier with a negative charge? The oxygen. And it's because of electronegativity. I like to think of electronegativity as it's how tightly an atom wants to hug onto electrons. So if something's really electronegative, it really likes hugging onto electrons, so it doesn't mind negative charge as much. Whereas something that's less electronegative has a harder time with extra electrons. The flip side of this is if you have a positive charge, do you want that positive charge on an oxygen or a nitrogen? Nitrogen, because oxygen really wants electrons and you're really not giving it electrons with a positive charge. So this kind of informs which is more stable. We have some rules for drawing resonance structures. Total number of electrons need to stay the same. The single bond framework stays the same. And this one's going to come back later. The hybridization of all atoms must stay the same across resonance structures. So we'll keep that in mind when we do an exercise in a minute. Now, we're going to do a lot with arrows in this class. And so can I just get like a show of hands? In a previous course, who has used curved arrows to show movement of electrons? Okay, a handful. Was that like in LS 1A? Okay. Or yes? Okay. Cool. If you have not seen it before, no worries. In organic chemistry, we use a normal arrow. We call it a curved arrow, so we never draw it straight. We use curved arrows to show the movement of electrons. And specifically, if it has two like little prongs here, it's the movement of two electrons. So a normal arrow means two electrons are moving. It always starts from some source of electrons, and it's going to a specific location. Later on, we'll get to single fishhook arrows, which are one electron moving. And then there are a bunch of other arrows, which you might have seen before, which you'll encounter. But I'm not going to talk through all of that. For resonance, there are basically three valid moves of arrow pushing that can get you from one resonance structure to another. So you can either start as a pi bond and take electrons in the pi bond and move it to a lone pair. When you do that, you've gotten rid of the pi bond, you've robbed this girl of electrons, so she has a carbocation, and then you put a lone pair on this carbon. You can go backwards. So the second move is going from a lone pair to a pi bond. So that creates a pi bond here where there was an empty p orbital in a lone pair. And the third one that you can do is go from one pi bond to another pi bond if there's a carbocation next door. So like you can see kind of examples of like here in Gen Chem, they cared about you just drawing the two resonance structures, right? Like the double bond up here and the double bond over here. But now we also want you to be like, okay, how could I move electrons to go from one structure to the other? So the way that I would recommend doing it is look at the molecule and say, where is there a source of electrons? Well, a negative charge is a great place to start. So here we took a lone pair, and if we have a lone pair, there's only one valid move we can do. We can turn that into a pi bond. Now, if we go to make this pi bond, this carbon already has 4 bonds. So a carbon with 5 bonds, is that allowed? No. Specifically for organic chemistry, we call it a Texas carbon because it's outlawed. And then I do have a sound cue.
This ain't Texas.
So if we make a new bond, we have to break a bond. So the only bond that we can break is a pi bond to a lone pair. And that's how we get to the other structure. So let's look at a practice together where we're doing some of these. So for this, you're given a structure and you're asked to draw the next best resonance structure. So to start you out, without doing any thoughts, smooth brain move that's like super strong, just draw the single bond framework. You know all the single bonds are going to stay in the same spot. Okay, and then I want you to take a couple minutes and I want you to try to, starting with the structure on the left, draw arrows to get to another resonance structure. Make sure to like look out for things like formal charge. Remember like the valid moves that you can do. And then once you have both structures, circle which one that you think is most stable. So I'll give you a few minutes.
so I never have to breathe. What am I doing? Thinking you're right. What are the chances? What the hell am I like? I'm usually polite. If you wanted my attention, I'm all in, no hesitation.
So, you might not be done. That's fine. Let's try it. So this top one, where is a source of electrons where I could start an arrow? The bottom oxygen with a negative charge, right? So we can imply lone pairs. The only exception is if you are going to use that lone pair, you should draw it. So like you don't need to draw these lone pairs over here because we're not doing anything with them, but one that you're about to draw an arrow from, you should draw. Okay, lone pair, the only thing we can do is make it into a pi bond. And then, is that nitrogen okay with 5 bonds?
This ain't Texas.
So what do we have to do? We have to break the double bond, because remember, the only bonds that we can break in resonance arrows is a pi bond. And we put on the other bonding partner over here. So what that turns into is we'll have a double bond here going down, and then we're going to have just a single bond up to the right. And then we're going to go from having, initially we had 2 lone pairs. This makes a third lone pair. We are taking the electrons that were in that bond, making a lone pair, so this has a negative charge. And then this nitrogen still has 4 bonds, so it still has a positive charge. Cool. Now between these two, which is more stable? They're equally. Everyone has a complete octet, and we still have the same charges on the same atomic species. So negative on O, either way. So equal. Over here, where do we start our arrow? Where's our source of electrons? Oxygen up top. All we can do is push down, make a bond, and then this carbon already has 4 bonds, so we have to break a bond. Can we break this sigma bond? No. So all we can do is break this pi bond. Could I move this pi bond down here? So this is where your mind plays tricks on you. You see this and you say, a line. That would look so pretty. However, this carbon has 2 hydrogens over here. This carbon has a full octet. And so if you make another bond to it, then suddenly you are yet again in Texas. Which, Texas, right? Yes. So, sorry, this ain't Texas. So what we have to do is we have to break this pi bond and just move it to a lone pair. So we have a CO. Sorry? No. That's not the natural world chemistry. That's some creative role-play chemistry. Okay, but now between these two, which is more stable, the one on the left or the right? Well, we look at where our charge is, right? So we have negative on O or a negative on C. Who's more comfortable with a negative charge? O, because she's more electronegative. So this one is less stable.
Do we have to draw the lone pair when we move to that carbon?
No. Like you can. It's a nice like detail sometimes, but like I'm grading you, and if you have a negative charge, I assume you know what's going on. If you had a lone pair there and no formal charge, though, I do have to count off for not putting a formal charge. You always have to have formal charge. Then over here, on the last one, our only source of electrons is the pi bond, so we can go pi bond to pi bond since we have a positive charge next door. So that shifts our pi bond on the right and makes a carbocation on the left. So these positive charge on carbons each time equally stable.
Could you repeat what this last one was?
Yes, so this is pi bond to a pi bond because we have an empty orbital here, so this can accept electrons.
Okay.
If this had a hydrogen, no go. But yeah. Cool. The last thing I'm going to do in the last like 5 minutes here is something you did learn in lecture yesterday, but it always trips up students. They always miss questions on the exam. And I think it's because she doesn't have a good publicist. So I said, I'll be your publicist. I'll do some branding. I'm going to introduce you to the neighbor rule. So typically, if an atom has 4 electron domains, we say it's sp3 hybridized, right? That's our like table. And typically, that table is going to work 95% of the time. 4 electron domains, sp3, 3 sp2, 2 sp. There is one exception, and that is the neighbor rule. So atoms that 1, appear to be sp3 hybridized on first glance, 2, have a lone pair, and 3 are adjacent to a pi bond or an empty p orbital. And when I say adjacent, I'm talking about like next door is a pi bond, not the pi bond is at that house. It's next door. If it satisfies all these, sp3 appearing, lone pair, and next to a pi bond or empty p orbital, it is actually sp2. It is not sp3. So let's look at this auction. Does it appear to be sp3 hybridized because we have 4 electron domains?
Yes.
Is that a lone pair?
Yes.
Is it adjacent to a pi bond? Yes. So what it's going to do, it could just be like, I'm just going to put my lone pair in an sp3 orbital. I'm normal. But then it says, I have a sneaky idea. If I hybridize sp2, I can put one of my lone pairs in a p orbital. If it's in a p orbital, what can it do? Delocalize. It can do resonance, and resonance is stabilizing. So if you were an oxygen and you had the choice between delocalizing one of your like lone pairs or not, you're going to delocalize it every day of the week. So this girl, even though she appears to be sp3, she's sp2 hybridized. This is the one that I think that you did in lecture here. So this one appears to be sp3 hybridized, has a lone pair, and is adjacent to a pi bond. And it's going to hybridize sp2 to put its lone pair in a p orbital so that it can delocalize with the electrons in the p orbital of that pi bond. Similarly, if you have a carbocation, that's a vacant, empty p orbital. And so you have the same kind of thing. Versus over here, this one has no incentive to hybridize as sp2. There's nothing next door to spread out electrons with and do resonance, and so she's just going to be sp3. Fair enough? So the last thing that we will do together is this practice, which is from challenge problem 7. So for the N's and O's, we want to determine the hybridization, and we want to determine what orbital the lone pair is in. So I'm going to start off with this far oxygen here. So 1, does it appear to be sp3 hybridized? Yeah, because remember, it has 2 implied lone pairs. Does it have a lone pair? Yeah. And then is it adjacent to a pi bond or an empty p orbital? No, there's something in between. So this one, what hybridization is it? Just sp3, boring. This girl, nitrogen, does she appear sp3?
Yes.
Does she have a lone pair?
Yes.
And then is she adjacent to a pi bond or empty p orbital?
Yeah.
So what is she?
sp2.
sp2 by the neighbor rule. So for this one, the lone pair, is it going to be in an sp2 orbital or a p orbital? P, because the whole purpose is to put the lone pair in a p orbital so it can delocalize. Versus oxygen, this one is a lone pair in sp3 orbital, because that's all we have. How about this bottom nitrogen? Does it appear sp3? So I'll draw in the lone pair. How many electron domains does it have? So what does it appear? So are we in neighbor rule land? No. So this one's just sp2. So here, if I had to ask, okay, what's the lone pair in? Is it in an sp2 orbital or a p orbital? sp2, why?
Because the p orbital is being used for the pi bond.
A. So the lone pair is in an sp2 orbital because it only has one p orbital, and that p orbital is preoccupied. That p orbital is doing a pi bond, so it can't have the lone pair. Great. And then the top nitrogen over here, last one. Does it appear to be sp3? Does it have a lone pair? Is it adjacent to a pi bond or empty p orbital? So what is it? sp2 by the neighbor rule. So its lone pair is in what orbital? There you go. So on the first page of the exam, on the first exam, you're going to have to do like 6 hybridizations. At least one of them is going to be neighbor rule. So know the one exception and don't get points counted off for it. But I will answer some questions after section here. Thank you so much for coming. I appreciate it. I look forward to seeing you in lecture tomorrow. And again, I'm around to ask questions if you have logistical things or content things. But